Yes, guys, welcome to our today's class. This is the 10th days of this week. Congratulations to everybody. You did all the labs I've sent to you. I've seen your work and I'm very happy. Hope you are going to improve and continue like that, right? So congratulations once more again. Just, I wanted just to remind you that this whole week, we are going to do chapter 3. Hope in Friday we are going to be done. And next week you are going to write your first exam. That exam will take 3 chapters. So we call it a module. So 3 chapters for 1 exam, right? So whatever that we did in chapter 1, chapter 2, and chapter 3, right? So what I'm going to do today, I'm going just to introduce you to chapter 3. And from there, we can move forward, right? But make sure that when you got some difficulties at home, you contact me, right? So I'm gonna try to share my screen in order for us to start, right? Where is what I wanna share? It's not even in there. Okay, let me look for it. Screen. My PowerPoint is not visible. First, you can see my screen. Yes. Yeah, okay. Yeah, so we are going to talk about protocols and models, right? Protocols and models. Let me first just try to check. Yeah. Let's start. Okay. Number 1, we are going to talk about communications fundamentals, right? Communication fundamentals. So I don't know if you can see properly. Let me try to move a bit. Okay. So when we are talking about networks, you need to understand that there are various sizes, and we discussed about that. When we are talking about networking, we can see that there's different sizes and complexities, right? But what you need to understand is when you are dealing with networks, those computers that are going to be connected will use specific languages, right? Specific rules. Those rules, we call them protocols, right? So when you connect your devices, you create your network, right? For your devices to talk, your devices will use certain rules or certain principles. And those principles will be called protocols, right? Now, your device that you are dealing with needs to know how to communicate, right? Your computer and your friend computer needs to know how to communicate, right? By using that specific or those protocols, right? So computers, when they are connected, they are using same languages. They are using same principles or rules that we call protocols, right? Now, when we are talking about the communication, right? There are 3 elements that you need to understand. Number 1, it's what we call the source. The source is the one that will be sending, the sender. And there is the destination, the one who's going to receive, and there is a channel. Channel means the medium that you're going to use for sending your message. So your computer, the one that's gonna send, will be called a source or a sender. The computer that will receive, this is the destination. And if you are using wireless, wireless is your channel, right? Or if you're using a cable, those cables, this is your channel. So those are the three elements that we have to consider when we're talking about communications, right? Source, destination, and channel. Let's move forward. Yeah. As I said, very, very important, right? When you create your network, right, your devices need to speak the same language. Your devices need to speak the same language. Your devices need to follow same principles, same rules, right? Those principles, those languages, we call them protocols, right? So they are just software, right? So protocols, they are just software, and those software will come with rules, right? Very clear. So when we are talking about protocols, those are the languages, right? Or the rules that your devices need to follow in order for them to be connected or in order for them to share information. So it means this: when you got your phone, you are chatting with your friends. Your phone and your friend's phone need to speak the same language, needs to use the same principles or rules that we call protocols, right? So when you're talking about protocols, that's a software with rules. That software knows how to make your devices talk, right? So your devices will have to follow those principles, right? Now, those principles will depend because we do have so many protocols, right? We do have so many rules, right? And those rules will be specific to a certain protocol. Like protocol A, how to connect phones, will be different with a protocol B, how to connect like printers, and will be different maybe to protocol C. So for every protocol, there is specific rule, right? So if I want to resume or to summarize myself, I will say this: we are talking about protocols. Those are the rules, the principles that your devices need to follow for better communications, right? So you can see computers can talk, you can send your emails, you can be connected to the internet because they are following the same principles. They are following same rules. Those principles, we call them protocols, right? And there is a protocol for a specific task. That way there are so many protocols, right? Let's move forward. And before even moving forward, I told you that for any communications, there are three elements that you need to understand. There is your source. There is a source. Source is the sender. You, when you have your phone, you're gonna send a message to your friend. You are a sender. You are the source of the message, right? And your friend gonna receive the message is the receiver, right? Or the destination. And you are going to use what we call a channel, right? The media that will allow you to communicate. Maybe it's via wireless. Wireless is your channel. Maybe it's cables. Cables, this is the channel that you use. So sender, source, no. Sender, receiver, and channel, right? Now, you can see this diagram. This diagram shows, we demonstrate how the communication happened. You can see here, there is a message. You got your message that you are typing, right? You got a transmitter, right? So transmitter is the device that you are going to use to send your message. And you got the transmission medium. Transmission medium means what? Which way are you gonna communicate? By using what? By using wireless or by using cables, right? And when your message will go, the receiver will do what? Will receive it. The device from the receiver and the destination will be done, right? So you got your message, You got the transmitter, the device that you're gonna use, and you got the transmission medium or the channel that you're gonna use, wireless or wired. And when your message will go, there must be a receiver, a device that will receive that message, and the owner of the message will receive, right? This is just the meaning of this message. We are just at the beginning, so we are showing you how the communication happens between computers, right? So you got your message, but you must use the device, the transmitter, and that device, when you finish the typing, there must be a channel, maybe wireless or using cables. And when you send your message will be received by a receiver, right? The destination device and done. This is the meaning. Okay, now let's talk about rule establishment, right? As human beings, for us to talk, we need to have rules or principles, right? Like for you to talk to your friend, you must have, you can use the same language. You can use isiZulu, but isiZulu is an agreement, like set of rules, right? So for any conversation, there must be some rules, some established rules that you have to follow. The same as devices. When you connect your devices, those devices need to follow same rules, same principles for better communication, right? So if one device doesn't follow those established rules, it's going to be very difficult for the receiver to understand or to get the message, right? So both devices, sender and receiver, need to have like established rules for them to communicate properly. It means this: when two computers or thousands of computers are connected, means that they already established some rules, right? And those rules, they are just protocols or software that knows how to connect them, right? So when you see computers are connected, means they are following some established rules, right? You can see those two examples. This first sentence is wrong, it's not well formatted. If I can send you this message, you cannot understand what does it mean, right? But if I'm sending you the second one, I am in class today, you can see it's well formatted, the same as computers. When you format it wrongly, your message will never reach the destination. Or maybe your message can go, but the receiver won't understand the message. So all this means a computer needs to have common agreements, or devices like in your network, they are using common agreements in order for them to be connected, right? Now, there are some requirements because we're talking about protocols. There are some requirements that a protocol must have, right? Those are the requirements for protocols. Number one, a protocol must be able to identify what? The sender and the receiver, right? Sender is the one who's sending, or the device that will be sending, and the receiver, the device that will be receiving. Number two, grammar or languages, right? So your protocols will use languages and grammars. Devices need to understand those languages or grammars, right? And devices need to agree on the speed. What does it mean? It means when you got two phones, when my phone will send a message faster than yours, right? If I can send you a message that you are going to receive it late, or maybe your your device is very low or it's very slow, that's gonna be a huge problem. So two computers need to have a common agreement when it comes to speed. Not one talking or working faster than the other one, right? It's going to be a problem. And the timing of delivery means that they have to agree when to send and when to receive messages, right? So when we talk about the protocols, you must know that the protocols must have those requirements. Number one, must be able to identify the sender and the receiver. Number two, a protocol must use the common language and grammars. Protocols must have a common agreement, like in terms of speed and timing of delivery, right? So your computers, the way you are sitting there, you see them, they are connected. They are connected because the protocol used, the software used to connect them knows how to identify the sender and the receiver, number one. Number two, those protocols will use the same languages, or those computers, they must use the same languages, right? And the speed, those devices in front of you, those computers need to agree in terms of speed and when to receive or send messages. This is timing of delivery. So we just seeing how the communication happened in order for you to have an idea. You are not there to write or to make those programs, but to understand how those programs works, how computers are connected, right? Because there is a software that knows how to identify a sender and the receiver, right? How to make those computer talks, how to set up at the speed and so on. Now, beside that, right? There are also some other requirements that computers need to follow, right? That we are going to talk about now. There are almost 5. There is what we call message encoding. Number 2, message formatting and encapsulation. Number 3, message size. Number 4, message timing. And number 5, message delivery. Right? But I'm going to explain one by one. Okay. What does it mean by message encoding? Right? Message encoding is the process of converting information into another acceptable form for transmission. So when you have a protocol, one of the requirements that your protocol must do, your protocol will encode messages. Encoding means when you write something, that protocol will convert it like in a way that's gonna be very easy to be sent maybe via cable or via wireless. So when you are sending your message, there is a protocol. That software will encode your message to make it very easy to be sent via wireless or via cable, right? And decoding is the reverse. Decoding is the reverse. So when you're gonna receive that encoded message, you have to decrypt it, you have to decode it to understand the meaning. So encoding means you convert your message. Decoding means you decode it, you understand back, you try to understand the original message. So that protocol that connects computers, that protocol does what? Will allow you to encode your message and to decode. This is the meaning of message encoding. There's no need for you to configure. There is no need for you to write a software or to make a software for that, just to understand in order for you to have a good idea how our computers are connected, right? Number 2 is what we call message formatting and encapsulation. So your protocol can encode and decode messages. Your protocol can format messages and encapsulate messages, right? You know, when you are sending your friend a message, your message must follow certain format or structure in order for your friend to understand it. Because if you type it wrongly, your friend will never understand the meaning of your message. Same as the computers, same as the devices. When you connect your devices, those devices need to follow some structures of formatting when it comes to sharing of information. So if they don't follow that, there won't gonna be proper communications. And your protocol will make sure that your message will be well formatted and encapsulated, right? Message size, right? When you are sending your friend a long message, it's going to be very hard for him to understand the message, right? It's going to be very hard for him. The same as computers, right? There's a maximum size of messages that can be sent from your phone to another phone, from your computer to another computer. And your protocol will make sure that the proper size of your messages will be sent for better communication, right? So you need also to understand this. Number one, messages that you are going to send will be converted into what we call bits, 0 and 1. So when you are typing a message, you are sending to your friend, your message will flow as a 0 and 1. When you are typing a Gmail message, means your message will flow as a 0 and 1 as bits. Number two, those bits, your message will be converted first to bits, 0 and 1, but that will depend to the type of what medium that you are using. Are you using fiber optics? This is light. Are you using a crossover or straight cable or whatever? This is the electrical impulses, right? This is the meaning. So when you send your message will be converted to 0 and 1, right? And your 0 and 1 will depend on the type of the cable that you are using. If you are using a fiber optic, your signal will be as a light, right? Now, when the destination will receive your message, the destination needs to decode it, needs to understand 1 and 0, what does it mean? So it means this, when I'm sending you a message, that message will be converted to thousands of 0, 0, 0, and 1, 1, 1, right? But when you are going to receive that message, you have to decode it again. You have to understand the meaning of it, right? Now, there's what we call message timing. Your protocol, we spoke about size of the message, we spoke about the formatting and so on. Now we're going to talk about message timing. Your protocol will control the timing between devices, right? You see, when you got two computers, those two computers need to agree on how much information to be sent and the speed, right? So when you connect your computers, the way you are sitting, those computers, the way they are connected, right? They already agreed on what? Speed and how much information to be sent. But you cannot do it. You have just to understand it like there is a protocol that will make sure that those computers agreed on speed and how much information to be sent. And that protocol is just a software that's going to be on those computers, right? Number two, it's response time out. So we call it flow control. Flow control means checking at the speed and the quantity of your information. Response time out, right? Messages how long a device waits when it does not hear a reply from the destination. So your protocol also will make sure that, suppose like you are sending me a message, right? Via Gmail, we are connected using the same network. How long I have to wait? My computer has to wait before sending a reply, right? Because if I don't get a reply, I have to inform you. There must be a message that will tell you like, I don't get the message. And your protocol will make sure that's going to cover. There's also what we call access method, right? So access method means your protocol will determine when someone can send a message. You can connect many computers. Those computers, they cannot talk like at the same time. There must be something that is controlling them, right? This is what we call access method. So your protocol will make sure that your computer can talk now or not, all right? Beside that, there's what we call message delivery options, right? Your protocol will make sure that your message goes to the right person. There is what we call unicast. Unicast is one-to-one communication. Means this: when you have your phone, you are sending a message to one person, to another phone, or to another computer. We call it unicast. Unicast is one-to-one communication. It's computer and computer, they are communicating. Multicast means one computer or one device talks to many. So one computer, but that computer is trying to talk to many other computers, right? Broadcast means one message that goes to all, to everybody. So you got one message and you are sending to everybody the same way we are receiving some SMS from Telecom, from Celsi, right? We can sit like this and we are receiving those messages like all of us at the same time. We call it broadcast. So there are three options. Unicast is one-to-one communications, one device sending to another device, and there is multicast, one to many, and there is broadcast, one to all. Right? This is the meaning. This is what I wanted to just to understand the concept of what? Of what we call protocols. All right? Very, very easy concept. There is no practicals on this one. What you need only to understand is how computers are communicating. When one computer is gonna start like talking to another computer, how we can call it? We can call it unicast. When one computer can try maybe to talk with 5 computers at the same time, how we can call it? Multicast. And when one computer will try to talk to all other computers, we call it what? We call it broadcast. And so if I want to go back again, I told you about flow control, checking how much information can be sent and the speed between your computers. Response time out. How long I have to wait before sending a reply. And access method, right? It's when your protocol will try to check which device is allowed to send a message, because everybody cannot send at the same time. So just to summarize, we're talking about protocols, and you have to go back to this slide. I will send it to you. You can revise today's lesson, and I'm going to send you the homework. Thank you very much. See you tomorrow.